Hello everyone, welcome. We're starting this presentation from Baurzhan and Tobias. They are going to present about Isar.
Thank you. So welcome to our presentation about building Debian-based products with Isar. A couple of words about us. My name is Baurzhan. I work for DebConf, and this is Tobias. He works for Siemens. So a little bit of an overview what we are going to talk about today. The first time we presented Isar at DebConf was in 2017, and at that time we talked about why do we use Debian for building products, and why Yocto exists, and why do we want to pick the better elements of both into a new system. Then we explained what is Isar, how it works, and how to perform basic tasks. Then in DebConf 2021, Francois presented typical use cases during the development and short examples how to use that. So today, in the late Friday evening before our dinner, I would like to shortly talk more about more conceptual points, like give a refresh and update on Isar, what is new, and what are actually the typical projects where we want and where we do use Isar with some specific examples. So for those of you who are not familiar with Isar, a short summary. So this is an open source project. We use Yocto's BitBake and create our own classes and recipes to build Debian-based products. The concept is quite simple. We take our product-specific applications as a source. We build Debian source packages, we build Debian binary packages, throw this into an apt repository, we debootstrap a root file system, apply the necessary configurations and customizations, and then we create the complete image for our product. So the first question that arises when we present this is, but yeah, look, product ABC is already available, and why do you want to specifically reinvent a new thing? And here we need really to look back at our specific needs in the product development. So to recap, we need to compile, to bootstrap, to customize, and to create images. So we need like a single stop tool set that would cover all these intermediate steps and has a powerful, abstract enough language to express these all types of tasks, and does this on demand, as opposed to, for example, some build daemon which produces packages from the queue. So these three features are provided in Yocto's BitBake. So it does it for us. We don't use the Yocto classes for that and develop our own classes and recipes to do that. And what I personally like about that is that it also supports more than that. Like today's products are usually not created by one team. It's usually teamwork of several teams or even companies. Like you take a SOC from a hardware vendor, it usually supplies you a board support package, and then you want to put your applications together, drivers, and so on. So often multiple teams are involved in this kind of development. Even, for example, many projects choose not to use the SOC directly, but they buy systems on modules from intermediary hardware companies which provide their own BSPs on top of SOC, BSP, and so on. So this kind of layering is provided by BitBake and allows for the collaboration. Another point is to make simple things simple and to still have the complex things possible. This is also possible with BitBake, and for example, you can start a new product. You take the Yocto BSP for that, you take the bootloader and the kernel, provide your product-specific application in one layer with one image, and you are done. This is pretty self-contained.
Hang on, we've lost you.
Yeah, switch headset or immediately it is strong.
Press and hold the button until the light comes on. Do you want a hand? No, not working. Turn the batteries.
It's on. Should be good. Just with this. I think it's working.
It's working.
One, two, three.
Thank you.
Okay, so we were talking about self-contained project with one image for one product. The next step maybe is that the products sometimes are not standalone, but are rather a part of a product family, where you can have a rack of 20 boards that maybe share 80% of code, but have some specific board-specific customizations or functionality or configuration. In this case, you actually don't want to copy-paste your configurations 20 times and then change it one by one if you have found a bug somewhere. So BitBake's dependency hierarchy allows you to share the code without actually duplicating it. So we, before we started developing this, we of course looked around and evaluated various tools. They do exist and they have overlapping feature set, but for our use case, compile, bootstrap, customize, create image, the necessary parts were missing in every tool. So mostly it was the compilation where either the toolset was not supporting it technically, or the designers even have taken a very conscious decision and said, no, we don't tackle compilation. The user should compile the thing himself. He should provide us the apt repository for that, and we will use this apt repository with binary packages to assemble the image. And this is the point where actually the reproducibility is not guaranteed, because if every developer does this on his own, then it's hard to ensure that the next time the result is the same. That is why for us it was a hard requirement that we automate this step, that we describe it in the toolset language, and that we are able to do that repeatably, automatically, and are able to verify this. So how do we do this? Before we started, we basically had two possibilities. One possibility is to develop our own tool, or BitBake was a good candidate. Now let's see who is familiar with Yocto. Okay, half. That's good because we decided basically that Yocto's BitBake is covering our maybe 80% of our requirements, and it has large community of people who are familiar with that, who know how to use it, how to debug it, how to read it, how to write new stuff for that. And it is also flexible enough so that we can develop our own classes for DPKG build package, S-build, Debianization on the fly, and so on. The only maybe disadvantage is that it doesn't understand Debian's metadata out of the box, but this is what we are working on currently. Then for the image creation, we are using also Yocto's Vik tool, and also what is provided in the Isar core functionality is to archive the binary and source packages with the purpose of later rebuilding or license compliance checking. The rest, the specific product functionality is implemented in downstream layers that are using some classes and recipes from the core. So we test this on a GitLab server, and for test cases we use Avocado test framework, but this is not a must, and our system is being used also, for example, in Jenkins or Azure environments, and also other test frameworks can be used for developing test cases. A couple of words on community work. So, to our surprise, so we moved from shell scripts to BitBake around 2011, and we could actually implement a working system without heavily modifying stuff. There were a couple of changes needed, and they are meanwhile already provided to the upstream project. So currently we are using BitBake, and it is not patched, it is all upstream. Also we provided some contributions to Avocado project. This was mostly regarding maintaining the pre-existing Debianization. And now we are slowly coming to the point where we want to bring the two tool sets, or maybe even two communities, a step closer to each other. This means that we would like that BitBake is able in some way to understand Debian's metadata natively, and so that we don't need many translation layers between them. So here what we expect actually changes probably in bitbake and probably also at the Debian side. Currently, the first step where we started is bootstrapping and Debian dependencies. So currently we use apt for bootstrapping, choosing the packages for bootstrap, choosing the right versions, and so on. What we need is a kind of introspection into this work. This means the tooling needs to be able to extract information, which packages have been chosen, which versions have been preferred due to which pinning, and then from which specific packages file this has been taken. So this details, I think we probably will have to modify Python apt. We will see. So this is currently work in progress. Yeah, so now we are coming to the more interesting part. What are actually, who are the users and what are they doing with Debian? What kind of products and how is this all built? So, of course, one application area for Isar is, or let's say the main application area for Isar is creating images for products. This means we start from source files for the applications. We start from binary Debian packages for the base system. We mix all together and produce one file, image file, which goes to the factory. As soon as a product board comes out from manufacturing, the image is flashed on the board and the product should be ready to use after it is turned on. Well, after we are building images, of course, we can also build VM or container images, and we also do this. One example is virtual machines for our developers, where we can, for example, if someone is developing an application, the application develops, the application depends on a library, and the library depends on a driver. So this means that these packages, dependency packages, must provide their development files for this application. So we provide the developer with a VM image where he can apt get, build deb, my application, and the requirements, the development files and libraries are pulled together automatically by apt from the apt repository. So does this mean that this covers also IT use cases? In theory, yes. And we do see people coming from IT background who like Isar's feature set. In practice, I think we still don't have many of them because in IT, the people work with high pressure and demanding deadlines. And my impression is, I think bitbake and also package Debianization is quite a learning curve for IT people, and I think we don't have many constant users from them. But yeah, of course, if we are developing software using bitbake and Debianizing stuff, we kind of have to do this, and yeah, this we do use. Yeah, so this was basically all about the core project. The core project itself includes a couple of examples. How to build images, how to run them, maybe on Raspberry Pi or QEMU, but the actual interesting projects are done downstream from the core. The concept is again quite simple. We need some build environment with the dependencies that are needed for running the framework. We can create our own or use pre-existing Docker containers from the CAS project. Then we usually need at least a bootloader and the kernel, maybe some further libraries or drivers from the SOC. So we take this from the Yocto BSP usually. And we add a project layer and our software components. Then we build it and run it, test it, and so on. So at this stage, I would like to pass the mic over to Tobias so that he can show how this is done in practice.
Yeah, I will give you an overview how we do this at Siemens. So Siemens uses Linux in a lot of its products, like in trains, MRT systems, CNC and industrial control systems. See Jan's talk about that from the last DebConf, if you're interested in all of the products and the details. And what I would like to talk about is that all of these products that are Linux-based need some type of base image. And for most of our products, we depend on Debian, because most of the stuff we need is already packaged upstream, and we get all the quality control that the community provides, and we really appreciate that. Of course, we get all the security updates from the LTS versions, and overall, Debian is a great package for us. But at the same time, we have a lot of customizations that we have to add that are not upstream yet. Like we have patches for custom kernels that are not upstream yet and that have to be used in the images we have to add patches to bootloaders that should be added to the images before, or the patches have to be added to the bootloader, and then the bootloader has to be built from source before the bootloader is added to the image. We have integrations of over-the-air updates and secure boot related stuff that should be added to the image, and of course some product-specific settings and product-specific closed source applications. In total, this can become a large amount of customization stuff, and this has to be arranged somehow. And the cool thing is that Isar provides the layering functionality, as it is bit based. And you can think of a layer like just a repository where some of these customizations are bundled together. And these layers can then be imported and reused by other projects. Therefore, most of our projects look somehow like this. We always have Isar as base at the bottom, and we have 2 to 3 layers with some changes that are imported. For example, some board support package, hardware-specific customizations, maybe something with a real-time kernel, a custom real-time kernel that we use. Sometimes something like as we update that we want to reuse in that project. And on the very top, we have some product-specific configurations and maybe an application. And this scales very well in terms of reusability in our projects, as we can, for example, share this hardware-specific stuff over multiple projects, and these projects can work at the same layer, and we can join forces there. And as we abstract the product-specific things away from the base layers, these base layers can, from time to time, even be open source, as they don't contain any proprietary stuff anymore. There are some open source base layers that evolved over time around Isar that I would like to mention, because they offer a lot of useful stuff for people that want to use Isar, and also I am looking at them frequently if I need some templates. So the first one that somebody who gets in touch with Isar should look at is Meta Isar. It's a layer that is embedded into Isar. It lies in the Isar repository, and it provides different targets that allow you to play around with, for example, QEMU, or for Raspberry Pi. So you have everything there to build a Raspberry Pi image and add a custom application from one of the templates that are provided there. You have a Hello application and things like that. The next one that I would like to mention is the Xenomai images layer. It offers the Xenomai real-time kernel for different architectures. So if you want to evaluate the Xenomai project for your project, this might be a good place to look at. In addition, it has a very advanced CI pipeline that I will show later in the presentation. And if you don't know at all what the Xenomai project is and you have some real-time related stuff, check out xenomai.org for more information. CIP Core is the Isar layer for the civil infrastructure project. The civil infrastructure project is backed by the Linux Foundation, and it provides a layer for industrial and civil infrastructure projects. It offers integration for over-the-air updates, secure boot, different kernels, real-time as well as non-real-time with super long-term support up to 10 years. There are different companies that sponsor this program besides Siemens, Toshiba. Yeah. The Cymatic IoT 2050 is a relatively cheap ARM-based machine that's built by Siemens. And the meta layer to give you everything you need to work with this machine is open source completely. We also have an integration of SW Update and Secure Boot. SW Update is a tool for over-the-air updates, so you have everything included what you need there. And if you have a look at that layer, you can also see how SW Update and Secure Boot is reused from CIP Core. So the integration of these two comes from CIP Core and is adjusted as needed. So most of the time, Isar is used together with CARS. CARS is a tool that allows you to configure and build bitbake-based projects. It makes it easy to tie all the different Isar layers you are using together and to create multiple different targets. So, for example, if you're building for different machines. Further, you can use CARS container. It's a script that comes with CARS to build your project completely inside a container. So the only dependency you have on the host system is some container runtime of choice. If you want to have more details about cars, I can recommend this talk at the very bottom of the page. Just briefly to show you what a cars file looks like. This is the YAML specification that is used by cars to build some project. This one is from Meta IoT 2050. At the top, you have to choose some configurations. So the first 3 points are a distro configuration file, a target image recipe, and a machine configuration. And beneath that you see the repo section where you can see the references to the layers that are used together with the commit hash to make sure that we always use the same version of that. At the very bottom we have some additional configurations, some switches that are set that are specific to that cars target. So for example here Ccache is used. I wanted to briefly show you how easy it is to build in the CI. So at least for simple projects, it is really easy. It's just a one-liner. With the red square around, you can see the run command. This is a GitHub actions example. You can just call cars container as the Ubuntu images that GitHub Actions uses already provides container runtime. And the image will be built, and the rest of the file that you see is boilerplate, and at the bottom we have some lines that archive the big image that is created by cars. A few words about caching, because Isar offers some powerful caching capabilities since some time. We have Ccache on the one hand. If you're building packages from source, the artifacts can be cached. So, for example, if you're building a Linux kernel, this can be really helpful on rebuild. And on the other hand, we have state for the complete bit-bake artifacts. So the problem is if you start building in a CI, you normally don't have your state in the next CI run. So what do? We have some scripts in Isar provided in the scripts folder for state management. And these scripts allow to save the state as well as to load the state and do some maintenance tasks that have to be done frequently. So in our case, it looks like that after the CI run, the state is copied to an AWS bucket. And on the next CI run, the state is loaded from the same AWS bucket, and the state is there again. Of course, you don't have to use AWS. There are multiple endpoints in the scripts that you can use. For example, if you have some local or HTTPS endpoints that you want to use. To give you an idea how advanced CI pipeline could look like, I don't want to go that much into details here, but what you can see is the Xenomai images CI pipeline with AWS Kubernetes scale out. You can see that we built different kernels and different architectures all at the same time. And these these images are then used on real hardware using Lava. We deploy the images to real hardware and run some tests to do our quality assurance. So basically that's it. To do a really short summary, Isar helps you to build Debian-based images and to add customizations where needed. It's very important that we don't start misusing this, so our goal should always be to get the things we do upstream. It's just a bridge to do the things downstream until we get the things upstream, and to be able to add some proprietary stuff that can't get upstream. And I hope you saw that the CI integration with Cars container is really simple, and I was able to give you some examples and starting points if you want to start with either. Thank you very much. Do you have questions?
Thank you to both of our speakers. I do have a question. The question is that what can Debian do better to support you guys?
Yeah, yesterday we had a talk with Hector, and actually there are a few points that we addressed to him. One point was snapshot support, because it doesn't work quite well under load. So there we are in discussion how we can maybe support this. And other point was the learning curve for the Debian packaging. So this means that our customers first sometimes don't see the necessity to build. Why should we build Debian packages? In Yocto, I don't have to do this, and I still get a binary deb file. But this is I see it as our job as commercial service providers to convince people that they do want to have source packages. They do want to build it via S-build and not manually, and they do want to throw it into apt repository and not just hang them around somewhere in random places. But the second step is, of course, we have in Isar automatic Debianization class. This means for simple cases, it works out of the box. So we provide some basic information like maintainer and stuff in the recipe, and it is able to build a source package out of a random Git repository. But of course, in more complex cases, this doesn't work, and users have to do this themselves. There they struggle a little bit with documentation and tutorials. Some are available, some are maybe outdated. So here we are looking how to consolidate this documentation, how to maintain it up to date, and so on. So another point was that sometimes some interdependent packages, I don't remember exactly the names, but example is libgcc and glibc. So one package is updated first, the other one is updated next. So several times a year we see like a window of 2-3 days where these two are inconsistent. So we discussed this with Hector, and yeah, we will check and analyze what is the problem. Maybe we have some bugs, or maybe we can improve something. We will see.
So can everyone give a round of applause to both of our speakers? Now, if anyone has some questions.
Yeah, thanks a lot for the presentation. Could you please highlight the main features of this system in comparison to other similar systems? What is the best feature which you can say, okay, this is our what we are trying to present? Thank you.
Yeah, I would say the main selling point for this is the range of the tasks that we are able to provide and how we do this. So basically, we cover all these 4 steps, and well, if a system have been existing at that point, we wouldn't develop this. So it's certainly not something what I wanted to do. I wanted to take something which just works and lets me concentrate on my product. We couldn't find it, especially, as already mentioned, the compilation phase. It is a complex configuration management issue, and you want to have this automated and scripted and documented in form of code snippets in a repository so that it is repeatable. If you are maintaining products and stable branches and many boards and a product family, then I don't see other way. Yeah? So this is our lesson learned from this. So basically the concept is simple, 4 steps. When you add the scale of the product families and 20 cards and several stable branches and customer-specific installations, customizations, and so on, this is the solution. And the nice thing about it is both Debian and both and BitBake also allow you to downscale. So you want one image for one product, it works well. You are not busy with unnecessary details and filling up 1,000 templates. No, it just works. If it's small, it's small.
I think it hits a sweet spot with relying on Debian wherever possible. And if you need customizations, you can build from source. And I think that's pretty unique. So you can specify a package that is built from source with dependencies and everything. And this is built on the fly and added.
Yeah, thank you very much. I have the last question. And what is the result of this software? So it means that you are defining some kind of dependencies which you need in your image, maybe some hacks, because it's very specific to your product. And at the end, you're getting some kind of tag exec or archive, which can be then used for flashing new cards and for auto updates.
A complete image. Complete image.
Complete.
You can specify which kind of image you want, and you get, for example, a big image that you can flash to SD card or VM image or a Docker container, whatever you need. So we support a lot of different targets. We use Wig for the creation of the images. You can specify how the partitioning and everything should look like, where those things should be installed and stuff. So you get a complete runnable image.
Yeah, and also this is specified actually in your recipes. Normally, most people want complete images. This means partition table, bootloader, device trees, kernels, rootfs, and so on, in one file. But of course, you can also have tarballs for later, I don't know, NFS use, or you want some bootloaders for board variants that you then want to flash manually, or some debug versions, and so on. This you can all specify in your recipe, and then it will be deployed.
So the time is up, unfortunately, but thanks to our speakers And one last round of applause. Thank you.